Bam, it's true. In this video, we're going to talk about two of the properties of exponents, the multiplication property and the power property. We're going to do this to go into another section where we're going to be multiplying polynomials together, and in this video we're going to be doing a lot of the distributive property as well, and when you do that, you work with exponents a lot, with multiplication and power. So these two rules say, the multiplication property says that a to the m power, that's a base, some unknown base or a known base, to a power times another factor with exactly the same base, only a different exponent. Could be the same exponent, but we have this marked off as n. So a to the m times a to the n is equal to a to the m plus n. We're supposed to add those exponents when we multiply multiplication, when we multiply like bases. Now if we don't have like bases, we're not going to do any addition with the exponents. You'll see that in the examples that we work through. Most of my examples are going to be algebraic, by the way, but for this first one, since you may have never seen this rule before, we're going to do it with just numbers. And we have 2 to the third times 2. Now, when you write when you have a base written and you're dealing with exponents, if you happen to have a factor or term with what appears to be no exponent there, you want to assume that that's equal to 1. Because if it was 0, 2 to the 0 would be 1, and, well, it wouldn't be a base of 2. So we have 2 to the third times 2 to the first. Now, this is, according to this rule, equal to 2 to the 3 plus 1, which is equal to 2 to the fourth power. Well, is that true? And notice, by the way, that I did not multiply these bases together. Most of our examples are going to have variables in the base, and you won't be able to multiply those together, and occasionally you'll get thrown one with a base that is an actual number, and a lot of students will incorrectly want to multiply those together and do, say, like 2 times 2 is equal to 4. But you'd only do that if it was just 2 times 2, not 2 to the third. It has an exponent. Now, 2 to the fourth power, we're doing this with just pure numbers so you can see that at least with an example this rule actually works. 2 to the fourth power is 2 times 2 times 2 times 2, or 2 times 2 is 4, times 2 again is 8, and times 2 is equal to 16. Now, let me show you, again, that this rule actually does work. This is only an example, it's not a proof, but I want to rewrite this in another fashion. I want to take 2 to the third and multiply it by 2 to the first without using the multiplication property for exponents. Well, 2 to the third is 2 times 2 times 2. The exponent tells you how many times to write the base. And 2 to the first is just, well, 2. How many times did I just write that base? 1, 2, 3, 4, like I had up here when I added the exponents. So 2 times 2 times 2 times 2, mainly what I'm doing here is just expanding out that first base with a high exponent of 3. And we got 2 to the third is equal to 2 times 2 times 2. Well, that's equal to 2 to the fourth, which is, again, 16, like the rule said that we would have. Now, most of our examples are not going to have known bases because, I could say that that was just 8 times 2, which was 16. I wouldn't really need to rule the multiplication rule for that, but most of our examples are going to look something like this, where we have x squared times x to the fourth. Well, then that's going to be equal to x to the 2 plus 4, which is equal to x to the sixth power. We're going to be doing some more complicated examples than just this. Power property. Well, a to the m to the n power is equal to a to the m times n. Now, notice the difference here than what we had over here. With the multiplication property, each you have two bases, you have two factors. You have the same base showing up twice, and then we just added those exponents. Unlike with the power property, you have the base showing up only once, and you have sort of like this stacked exponents type thing here. Your textbook might have this horizontal, but it's like it's an exponent, a parentheses, and another exponent. Or I like to say we have stacked exponents on a single base. So that says that you're supposed to multiply those together. Well, let's try this. Let's try 2 to the second power raised to the third power. Again, with a number in the base, so when we're done we can do it in our heads with arithmetic and actually see with this example that this power property actually does work. Well, the rule says, when you have a single base and you have stacked exponents, you know, whether it's 2 to the third or like we have here 2 parentheses and a 3, usually there's a set of parentheses there. When you have those exponents touching or stacked, you multiply. So this should be 2 raised to the 2 times the third power, which is 2 to the 6. And 2 to the 6 is 2, 4, 8, 16, 32, and 32 times 2 is 64. Okay, so one base, stacked exponents, multiply those exponents together. Well, I don't know if this really works. I've never seen this before. So let's remember again that exponents simply tell you how many times to write the base. And this exponent of 3 here, you know, with this set of parentheses, you know, the 2 to the second power is the base that has the power of 3 applied to it. So if 2 to the third is equal to 2 times 2 times 2, then 2 squared to the third is 2 squared times 2 squared times 2 squared. Well, there's a couple ways I can do this. This is 4, this is 4, this is 4, and 4 times 4 is 16, and times that by 4 and you get 64 like we got when we used the rule. Or it's 2 squared times 2 squared times 2 squared, and we just learned that when we multiplied like bases we were supposed to add the exponents. So this 2 has its own exponent of 2, this 2 has its own exponent of 2, this 2 has its own exponent of 2, so this is going to become 2 to the 2 plus 2 plus 2, adding those exponents because I have like bases on them. Well, 2 plus 2 plus 2 is 2 times 3, repeated addition is multiplication, which is again 2 to the 6th, which is again 64. So I'm going to clear off this board. We're going to do a lot of examples. I got 1, 2, 3, 4, I don't know, probably about 8 or 9, 10 examples with you know, ever-increasing difficulty to really make sure that you got these rules understood. And they'll get, you know, a little bit more complicated looking and can be a little bit tricky. So I'm going to give you lots of examples to help you out. Woo! So here are our first 6 examples. We've got x times x to the 4th, a really basic example. When we multiply like bases, we want to add those exponents, but I don't see there a 1 there up there as an exponent, so you might want to add that in, and remember that when you multiply like bases, you add the exponent. So this will be x to the 1 plus 4, or simply x to the 5th. Over here now, well, the next screen when we have some exponents that are variables, we are going to assume that those variable exponents represent positive integers. Dealing with negative integers is something I want to do in a video. I'm going to do it coming up pretty quickly here, but not yet. So here we have negative x to the 4th. Now, for this one, I actually want to write this out and explain to you what's going on with the negative that's inside that parentheses. When this exponent is even, you can get some sign errors with this when you have negative numbers inside those parentheses. So let me show you what I'm talking about. We have negative x to the 4th power. Now that means with the power of 4 that we have negative x times negative x times negative x times negative x. And you know when you multiply two negative numbers together you get a positive answer. So negative times negative is positive 1. Now another negative 1 is negative 1 times another negative 1 is positive. All these negatives that show up in pairs will cancel that negative out. So we have negative 1 times negative 1 is 1, negative 1 times negative 1 is 1, and 1 times 1, all these negatives are going to cancel out to make a positive 1. And then we have x times x times x times x, or x to the 4th. Because we have 1 plus 1 plus 1 plus 1. So negative x to the 4th is equal to 1x to the 4th. Now, we have got in this example, really, I can re-illustrate this or rewrite this to show you that what we're dealing with is powers, or the power property. So I can write this as negative 1 times x to the 4th power. And now I have a factor of negative 1 and a factor of x. Each one of these has an exponent of 1. And when you have those stacked exponents, the 1 base has an exponent of 4. When you have those stacked exponents, now that I see, when I add in those hidden exponents of 1, that it is power to power. So we have negative 1 raised to the 4th power times x, and then, because that's 4 times 1. And then we have this exponent of 1, so we have x to the 4th power again, and negative 1 to the 4th power is, again, equal to 1x to the 4th. If you had, let's stick with this for just a second here, this negative 1 to the 4th power wrapped up inside the parentheses. Now, if I were to make another example, of negative 1 to the 4th, you need to remember that exponents only act on what they're sitting on. So the only thing that's getting the power 4 applied to it, is this base of positive 1, not the negative that's out front, because it doesn't have a set of parentheses wrapped around it like this example. So negative 1 to the 4th power, with the 4 only acting on that even power, only acting on that positive base of 1, this comes out to be negative 1, because 1 to the 4th power, 1 times 1 times 1 times 1 is 1, and then you still have that negative sitting out front. So be careful of your signs when you have an even power. If you have an odd power, it's going to come out to be negative either way. But a little bit of a sticky point there. We have negative x squared, and so it is only the x that's being squared, not the negative, so this is going to stay negative x squared, times x to the 3rd. So there is that 1 in there, and there's a 1 there if you want to see it, and negative 1 times negative 1 is, negative 1 times 1 is negative 1, and then your x squared times x to the 3rd, when you multiply those like bases, you add the exponents and you get x to the 5th. So negative x squared times x to the 3rd is negative 1 x to the 5th, or just simply negative x to the 5th. Here we have 3x cubed raised to the 2nd power. This is more obvious, that is power to power, the one base with the stacked exponents. And we see those stacked exponents, so it's a more obvious example of the power property as opposed to this first one that I did for you. Well, it's actually the second example, but the first one like this. So when you see these stacked exponents, it is power to power. You're going to have to multiply those together. But what do we do with the 3 that's out front? Well, that 3 also has an exponent of 1. So when we apply the power to power property, it's going to be 2 times 3 and then 2 times 1. So this is going to come out to be 3 squared, because 1 times 2 is 2, times x, and then 3 times 2 is 6. Now 3 squared is equal to 9. Whoops. 9x to the 6th. If you didn't know this power property yet, you could, and this is the best way to do it, but if you didn't know the power property yet, you could say, well, it's 3x cubed raised to the 2nd power. So this whole base is showing up twice. So it's 3x cubed times 3x cubed, and your 3 times 3 is equal to 9, like we had before. And our x to the 3rd times x to the 3rd, when you multiply like bases, see what I've written now? The base is showing up twice, each time with its own exponent. When you multiply like bases, you add the exponents, and 3 plus 3 is equal to 6. Same answer we got before using the power property. So you might go, well, why do I care about learning the power property if all I can do is just go, oh, okay, there's 2 of those bases and write it twice, and then put all those numbers and variable bases together. If it was to the 7th or 8th power, do you really want to write that base 7 or 8 times? So I'm just illustrating there's another way to look at the problem, especially if you're just learning the power property, but I would do this example how we did the first the first way. Here we have x squared times x cubed plus 2. Now we have a binomial, there's 2 terms, we have a binomial in the parentheses, so what we're about to do is the distributive property, where if you have a monomial in front of, actually it doesn't have to be a monomial, but we have a number in front of this parentheses, and that number, or factor in this case, that factor needs to get distributed through the parentheses. Now when I do the distributive property, I like to draw lines connecting whatever's in the first factor, connecting it to all the terms inside the polynomial, inside that binomial, inside those parentheses, and make sure that I follow each one of those lines and they do represent multiplication. So we're multiplying like bases, and when we multiply like bases, we add the exponent. So x squared times x to the third is x to the fifth, because 2 plus 3 is 5. And then plus 2 times the 1 that's in front of this x. So 2 times 1 is 2. Positive times positive is positive, so plus 2x squared. These are not like terms. Both of these terms have the same variable in them, so they both have an x. So you might think that they're like terms, but this has 5 of them and this only has 2, so they're not like terms. Please do not add them together. Here we have a little bit of a bigger monomial and a little bit of a bigger monomial. These two factors are being multiplied together. And instead of rewriting the 2 and the 3 together, the x's together and the y's together, I'm just going to color code this. We're going to put the coefficients together, the numbers, the 2 times 3. We're going to put together the like bases of x, and we're going to put together the like bases of y, not forgetting that this y has an exponent of 1. So we're going to do 2 times negative 3. These aren't exponents. They're right along the line of bases here. The exponent, this has an exponent of 1, this has an exponent of 1. So we're just going to do 2 times negative 3 and get negative 6. X to the third times x squared, like bases, add the exponents. That's going to be x to the fifth. And then like bases, y to the first, y to the fifth. That's going to be y to the sixth power. And that is the end of these examples. I've got no more remote now. I've probably got about 5 more of these to do. So hopefully the video is not getting too long for you and you're learning something that you need to do your homework. Woo! Last 3 examples. Or would that be 4 examples? Excuse me. We have negative x squared times negative x to the third power. Now I do have like bases here, so I can just add those exponents, but I want to really emphasize with you the difference between having a negative term inside of an even power and a negative term inside of an odd power. This is negative x times negative x. Now, negative 1 times negative 1 is positive 1, and x times x is x squared. So negative x squared is x squared. Now, when I turn my attention to the second factor, which has a power of 3, now it becomes negative x squared times negative x times negative x times negative x. Now, negative 1 times negative 1 is positive 1 again, but then it gets multiplied by a negative 1. So this becomes negative 1, positive 1, negative 1, and then x times x is x cubed. Now, I'm writing the negative 1 in there for practice, but we don't really need to write that. It's negative x cubed. So now we've got x squared times negative x cubed. Well, we're going to put those numbers together out front. We have 1 times negative 1, which is negative 1. I'm writing for teaching purposes. You don't really have to show that if you're getting your answers correctly, correct consistently. And then x squared times x to the third, multiplying like bases, add those exponents, and that becomes x to the fifth. So our final answer is negative x to the fifth power. Here, going back to distributive property, we have a monomial, x times y squared, being multiplied by a trinomial. There's 1, 2, 3 terms in here. The terms are separated by addition and subtraction. So this monomial needs to get multiplied through and, contact each one of the terms in this trinomial. So we have x to the first times y squared equals 4x. I'm going to go a little bit faster now because hopefully now you're getting used to the multiplication property. And when you multiply like bases, you add the exponents. Well, I'm going to add those in. This x has an exponent of 1, and this exponent has an x of 1, and well, actually this has a 1, and this has a 1, and this has a 1. So we have 4 from 1 times 4, so we have 4. X to the first times x to the first is x squared. And then, there's no other y, so y squared. And then 1 times 1, a positive 1 times a positive 1 is positive 1 again. And then x to the first times x to the first is x squared. Y to the second times y to the first add those exponents, we get y to the third power. And then 1 times positive 3 is plus 3. We have an x, there's no x in this term, so that just comes along for the ride. And y squared times y is y to the third. Now, at this point, if there's any like terms, we need to add those together. A like term would be, terms that have the same variable in them. Well, these all have x's and y's, but they also, again, have to have the same exponent. This has x squared, y squared, this has x squared, that's good, but it's y to the third, so these aren't like terms, these first two, nor is the third one. Also make note that I am not adding these exponents together because these are not like bases. This is an x and a y. They represent a different number, a different base. I know that because there's different variables there. If they represented the same number, they'd have the same variable attached, assigned to it, at least for our purposes here. So there's no like terms, and that means this problem's done. Here we have, get a little bit more complicated as we do these, get to these examples, and these are the last two. And thank you for watching. We're multiplying again the distributive property, like basis. So when you multiply like basis, you add the exponents. I'm going to write this one out. X to the a times x to the 3a plus 1, you're supposed to add those exponents. Well, this exponent is a, and this exponent is 3a minus 1. Plus, you're not going to change the rules just because the problem's a little more complicated. When you multiply, those like bases, you do add the exponents. X times x, like base, so we have again a, so x to the a plus 4 minus 2a. Now, you might be asking yourself, why am I using parentheses when I set up this addition? Because they're not really going to do anything. When we get to the quotient or the division rules, quotient rules, division rules, you need to be really, really careful about your signs. And if one of your exponents happens to be a binomial and you don't wrap that in parentheses and carry the negative that's in front of it through, you are going to get a wrong answer. So this is just good practice. It's not really going to change how I do these problems. X, okay, so we have x. What do we have in the exponent we can add? What like terms do we have? 1a plus 3a is 4a minus 1 plus x to the, let's see here, 4. That's a positive 4. A plus negative 2 is negative 1, so we have negative a, that's from a minus 2, plus 4. Now I'm not going to put these together because these are not like terms, so that problem's done. Our last one is a combination. We're going to do a combination of the power rule and the multiplication property, or rule. We have stacked exponents. This is going to be x to the ab power times, because there's a multiplication symbol there, they're touching, x to the, now these are stacked exponents, so it's going to be, you're supposed to multiply them. B times 2b minus a. I'm going to go ahead and, show that. So we have x to the ab power, these stacked exponents, times x to the b times b is b squared, so 2b squared, and then b times a is ab, or minus ab, because it's positive times a negative. Now, when you multiply like bases, because we haven't done that yet, these two factors both have the same base of x. When you multiply like bases, you add the exponents. So now we have x to the like base, ab, plus 2b squared minus ab, and ab minus ab is 0. So these are going to cancel out, and our final answer is x to the 2b squared. I'm Mr. True. Bam! Go do your homework.